Okay, let's get started. Hopefully all of you are having an amazing morning, amazing start at the conference. The talk is going to be about GitOps. Just to introduce ourselves first, we're from Synhasso. I'm a software engineer at Synhasso. It's been about a year and a half at the company. Before that, I was doing platform engineering and Kubernetes related works at VMware. And Jake?
Yeah, hi, nice to meet everybody. My name is Jake. I'm also an engineer at Synhasso. Prior to that, I was working at WeWorks for a few years, and prior to that, at Pivotal.
Okay, cool. So the talk is going to be mostly focusing on GitOps, but before we get started, I just want to have a few words about Kratix itself first. So Kratix is an open source platform framework that we're building here at Synhasso. One of its core functionality is the ability to schedule workloads to different type of destinations, and we're using GitOps to achieve that. And Kratix also is built and runs on top of Kubernetes, and therefore we're at KCD UK. So really, GitOps is at the core of how Kratix works. Okay, a bit of a refresher. What is GitOps? So GitOps is a way of managing your infrastructure and application code through using Git as a single source of truth. You would express your infrastructure setup and your application in code, and then you check that into Git. That will include everything from how to scaffold your Kubernetes cluster to specific software that you're running in your environment, or your application configuration as well. And then you have automation set up that watches these Git repos and then reconciling your environment to making sure that everything is in sync. Okay, so some core principles of GitOps. So first, your system must be declarative. You don't say how to get to the desired state. You simply express the desired state in code, in written document, and then you check that into Git, right? And because all of your changes are tracked in Git, changes are going to be versioned, and you cannot rewrite history. The history is going to be immutable. And when we're talking about GitOps agents, it's going to watch these Git repos, and changes are going to be pulled automatically. It's not going to be a one-off action. Similarly, goes to the continuous reconciled principle as well. Like actions are not going to be performed once. You're not just going to reconcile once and then forget about it. It's going to keep detecting, keep reconciling and making sure that there's no drift. Whenever the agent detects any kind of drift, it's going to apply over that and making sure to bring the environment back in line. Okay, so what would that look like in the context of Kubernetes? So you will have couple or one Git repository that are tracking all of your Kubernetes manifest. That will include maybe your config map, your deployment, your stateful set, or some Kubernetes operator that you're depending on, like Server Manager, or maybe like an in-house Helm chart that you're building and distributing to the rest of your organization. And then you have your GitOps operator. So your GitOps agents are, they're either Argo or Flux. They're great. They're built and runs on top of Kubernetes. And they will be configured to watch your Git repos. And usually they're also deployed in cluster to where they're applying the changes to. They're gonna pull the latest version of that you have in your Git repos and then apply them to the Kubernetes API. And from there, Kubernetes take over and is going to make sure that the actual state in your cluster matches the desired state. And just to re-emphasize on some of the principles that we talked about earlier, the one on pull automatically and continuous reconciliation. All of these errors, they're not going to be a one-off action. It's going to be continuously performed. Same for the agent, same for the Kubernetes API. Okay, so benefits for doing GitOps, why you should consider adapting it if you haven't done so. So first is it's easy to audit because GitOps really is emphasizing on the fact that you should express as much as you can in written document, and then you check that into a Git repo where people with the right permission, they can view these changes, right? And all of your changes are going to be tracked and versioned as well. So you're no longer relying on somebody's memory or maybe like a Slack thread that you can never find or some email conversation to check out the context. You can go to the Git repo and then look at the changes and also with a comprehensive history as well. And the second point is on it's easy to recreate your environment because we're using Git. It is versioned. So it also emphasizes on automation to set up an environment. So in theory, you can check out an earlier commit and take a look of what that environment looks like at that point in time, and even recreate your environment for that. And third is on developer autonomy. So teams don't have to push out changes by creating a ticket and waiting for the operation team to act on that. They can push out and propose changes by pushing to the repo directly that has GitOps setup, or they can just create some PRs. And third point is on reducing human errors because they really emphasize on automation. There's less of a need for human intervention, human actions. So hopefully it's going to reduce the risk on human error happening and impacting your environment. Okay, so now I'm gonna pass it to Jake, and he's going to talk about how we're using GitOps in Kratix.
Thank you, Chunyi. So like Chunyi was describing, there's lots of value in using GitOps, and we knew when we were writing Kratix that we wanted to make sure we leverage this. So the basic premise of Kratix is that it's a platform orchestrator. It's there to help you schedule workloads and deal with all the services you need to offer in your platform. And obviously a big part of that is you're using Kubernetes and deploying things to Kubernetes. So we have this basic idea that your platform is probably going to need to schedule workloads to various Kubernetes clusters distributed all around the world on different cloud providers. And we needed a way to easily be able to do that. So like we talked about, we wanted to leverage GitOps, but just saying that alone isn't enough, right? How do you go about doing that? How do you make sure it scales and it works quite smoothly? So we realized that we needed to introduce a component into Kratix to make it easy to schedule workloads to different Kubernetes clusters. So we started with this idea of, okay, we can write a scheduler in Kratix. You can give it some declarative manifests, and the scheduler will take care of writing it to the right Git repository in the right directory in the right branch that will be synced by the right cluster. Now, that was easy enough, but how do you actually make it useful and an API that's quite easy to interact with? And that was where we looked in the ecosystem for some existing examples. So the most obvious one, and the one that we decided to utilize, was the nodes examples in Kubernetes. So if you've ever spun up a Kubernetes cluster and registered nodes, you'll create a node, you'll assign some labels to it, and when a pod's being deployed, it can say, hey, I want to go to this particular node. And we decided to apply the exact same principle, but for scheduling GitOps documents to different Kubernetes clusters. So the idea being that you would register a Kubernetes cluster, we call it a destination, with Kratix, and you would associate a set of labels with it. So in this case, you might say labels about the region, you might say what capacity it has, like does it have GPU nodes, for example. You can imagine this could be quite complex. You could be saying which cloud the Kubernetes cluster is in, which version it is. Any set of properties that make sense for your organization, you can apply that. This approach was quite nice. It's unsurprising to Kubernetes users, right? Lots of people are used to label selectors and all that sort of stuff, so it was quite nice. So the basic idea we wanted to support to begin with was a platform engineer could say, hey, there's this workload that I want to schedule to multiple Kubernetes clusters, and I want to do it via GitOps. Just go and do it for me. So in this case, it could give you something like Kubeflow, and it could say, here's the manifest for Kubeflow, schedule it to all of the Kubernetes clusters that actually support Kubeflow, as in they have a GPU node label, GPUs nodes available. So in this case, Kratix would take that declarative document, write it to the right Git repositories for the right Kubernetes clusters, and have them be synced by those end clusters. And because it's using the label system, it would know, okay, this particular cluster, in this case EU S3, doesn't have this label, therefore I'm not going to write this declarative document to the state store, and it won't be synced. Once you've achieved that, you can then start doing more granular scheduling. So in this case, you might say, a developer might come to the platform and say, great, I want to take advantage of Kubeflow. I want to train my model. Go ahead and schedule this workload to me. And then the user's just coming to the platform and requesting this. The platform can then say, okay, I know I have these clusters that have Kubeflow already installed, and I know they're compatible. So when a user says they want to schedule this, I can just go ahead and schedule it to the workload for them. So this is quite a nice approach. It made it easy for people to interact with the platform. It made it easy for the platform to leverage GitOps. And it's just provided quite a nice sort of simple experience. But what we learned is that this doesn't just apply to Kubernetes, it applies beyond that. So I'm going to hand it over to Chunyi to talk about that.
Cool. So because we're talking about GitOps here at context of Kubernetes, and usually people think about it as Kubernetes cluster plus a GitOps agent of your choice, like Argo and Flux. But just going back to the earlier, to the starting point of our talk, GitOps is about a set of practice and principles. And so at the core of it, it's you express your desired state, and then you have you check that into Git. You're using Git as a single source of truth, and then you have automation that reacts to these written documents and then reconcile it in the environment. So technically, if you have seen a software that can react to written, that can be configured by a written document, it can do GitOps. So that's true for Kubernetes, right? Kubernetes is all about declarative state. You tell the API what the declarative state is through YAML manifest, and then Kubernetes take care of it from there. It's also true for using Terraform Cloud or Terraform Enterprise to manage your infrastructure. It's also true for Backstage as well. So Backstage developer catalog, they're all your components and templates that showed up in your Backstage are all configured through YAML manifest too. So if you identify that reconciliation behavior based on written document, you can use GitOps to manage it. And you're not limited in terms of the tool that you have to use. So we're oftentimes talking about Flux and Argo in the context of K8s because they're built on K8s, they run on K8s, they're K8s native, they're great, people loves it. But you're not limited to those two either. So we're all using CI/CD. If you're on GitLab, you're probably using GitLab pipelines. If you're on GitHub, you have GitHub repos, you're probably using Actions as well. So you can use those tools too. So you can use GitOps agents that are pulling changes from your repo, like Flux and Argo. But at the same time, you can also have your CI/CD setup that reacts to pushes, commits to your GitHub repos, and then relying on CI pipelines to push out changes to the environment. They may look kind of different in practice, but it's achieving the same goal at the end of the day. And that flexibility is really powerful, right? Because if you have to adapt a different tool to do this, like if you haven't used Argo or Flux before, we know that adopting a new tool always going to have a cost on the team, on the engineers, but we're always using some sort of CI/CD already. So you can rely on your existing tool to adapt GitOps. And in Kratix, we embrace this flexibility. We don't care which mechanism that you're using to reconcile the environment. It's still, when we are scheduling works and managing workloads by Kratix, it's just under the same GitOps contract. Okay, so bring back the story to Kratix a little bit. Imagine that you are a platform engineer and you and your teams are maintaining and deploying Kratix, serving that to the rest of your organization. And the demand has grown. So you are in maybe like three or 2 months ago, you're scheduling workloads to a bunch of Kubernetes cluster, and that was it. But now the demand has grown, so you're scheduling workloads to your Terraform Cloud account, your Terraform Enterprise, your Ansible, and things are working fine. They're reconciling successfully. However, as time goes, you feel like the visibility into the health and the status of your workloads that are scheduled by Kratix is becoming more and more a challenge for you. Because in the old world, when things are all running in Kubernetes, you can rely on your Grafana dashboard that are reporting the statuses of all of your running pod. It's nothing fancy, but it works, and it's a consistent way of looking at the status and the health of all of your running workloads. But now, because you have workloads that are running in different type of destination, they all have their own different way, they have their different language to express the status of the running workloads. And as the platform engineer, you kind of have to switch environment, switch the different mental models when you have to check on the statuses of all of your workloads. And it really just adds friction to your experience. You feel like it's adding unnecessary cognitive load to maintaining Kratix, running Kratix for your organization. So we got this feedback from a user. And we started here at Hasso, we started asking these questions about how we can pass information back from destination to Kratix itself. And we're thinking about, like, maybe we need a new type of connection, maybe we need to introduce an external database to get that information passed back. And that's not really ideal, right? Because we're talking about our enterprise users, and generally if you're introducing a new type of connection, you need to have new security sign-off, you need to have permission tickets created. It may take months to resolve them, if it's even possible to resolve them in the end. So that's additional requirements to deploy Kratix and additional complexity for a user to mind about as well. We just wanted to solve this problem without introducing that. Okay, so we looked at our existing architecture and we said, okay, wait a minute, we already have a way of passing information from Kratix to our destination, right? Because Kratix is scheduling workload to destinations through state store. It writes the workload document to the state store, and then you have GitOps agents in the destination that look at these state stores and then reconciling the work this way. But so far, the communication has been one directional. We're pushing workloads from Kratix to the destination, but nothing is saying that we can't use the same state store to pass information back from the destination to Kratix, right? And if we're solving problem in this way, we're not introducing a new type of destination, therefore there's no new security sign-off or tickets created that's necessary for our users. So that's the solution that we landed on. So we said that we're going to use our state store as a bi-directional communication channel. So in the old days, so Kratix would pass on workloads that it wants to schedule to our destination through the state store. And now we're saying that the destination can also write information back through the state store. So they're going to write information back to the state store, and then Kratix will react to that. And it doesn't. This will include all different type of destination. It's not just limited to Kubernetes cluster. It's the same for if you're using Kratix to configure your developer catalog for your Backstage instance or your Terraform enterprise account. They can all pass information back to Kratix by writing that in the existing state store. And then we say that we're going to have GitOps agents that are also deployed in the platform cluster where Kratix is running. And these GitOps agents are going to pull the information from the state store, apply them to the platform cluster, and then Kratix will simply react to them by updating statuses of the corresponding resource request or the manifest. So now, as the platform engineer, you have a consistent way of viewing the statuses and the health of your workloads. You can stay in the platform cluster, the same context, and then you can check on the statuses of all of your resources, and it's a coherent and consistent way of presenting that information for you. So we solved essentially this is a health check, right? And we solved this problem by leveraging our existing architecture and by using GitOps again. Okay, now I'm going to pass it back to Jake, and he's going to speak about GitOps beyond Git.
Awesome. Thank you, Chunyi. So as many of you might have noticed in this diagram, we're using the Git repository in the middle as a way of communicating information back and forth. And a lot of you might be thinking, does that really scale? You know, like when you're pushing out changes to Kubernetes clusters, you're doing that through Git. It's probably quite a low rate of change. You might change every few minutes, maybe every few hours. But if you're pushing information back to the platform cluster, this might actually happen more often, right? If you're health checking a critical application or a database or something like that, you might be wanting pushing information back every minute or every few seconds or whatever sort of configuration you want. So we quickly realized that this actually might not scale very well. You might have hundreds of Kubernetes clusters, all managing their own hundreds of workloads within them, all of them wanting to push information back to the platform about the health of those workloads. And if you're doing that via Git, you might have some problems. So one solution could be that you just introduce more Git repositories, but that doesn't really solve the problem, right? You're just sort of pushing it out a little bit. You're still going to have the same bottlenecks at the end of the day. So this sort of comes back to like, why are we using Git? So GitOps started as the main trend. Like Chunyi was describing, there's lots of benefits to using Git. You get that nice history. We're all developers that are familiar with it. You can encourage people to PR in changes. And it's just a very good user experience. But there's cons of it, right? You can't deal with concurrent pushes. You're going to get lots of conflicts. If you're using things like webhooks on pushes, it's going to be even more messy. So then we started to think about, okay, actually, does this need to be Git? So at the end of the day, we're looking for a place where you can declare what you want the state of the world to be, and a system can reconcile it. So another example of that could be S3. You could write documents to an S3 bucket and still have a system converge in it. You're losing some of the benefits of GitOps, being able to have that commit history, that easy ability to contribute, but you're trading it off for like a higher throughput. So in this case, you could write documents about the status of the workloads you're deploying really frequently because S3 scales really nicely. This is S3 compatible, so you could be using an open source product as well, like Minio, or any of the cloud providers that use different S3 compatible APIs. But now you've lost the GitOps part that you liked, you lost that ability to go and look at the commit history and see, okay, what changes were made. So what we realized that actually we shouldn't limit you, we should let you use a combination of both. So you could use Git for when you're pushing out information out to your clusters, so when the platform is pushing out changes, you use Git, so you get the nice history that you like. But when you're pulling information back out from the cluster and into Kubernetes, where the platform, into Kratix, you can use a different system. And this sort of mixing and matching, using the right system for the right scenario, we think is quite nice. We're not limiting you. You can push data out via one mechanism and pull it back via another. So it doesn't just stop at S3. Control Plane recently put out a blog where they're talking about what would a Gitless GitOps architecture look like, which is quite fun. And the example they gave was using OCI. So those of you familiar with Docker images, a Docker image follows the OCI spec. And essentially, it's just storing some documents in an OCI registry. So nothing stops you from actually using the same principle, but for storing YAML. So you could use a tool like Auras to build a Docker image that just contains YAML manifested in the day and push that to your registry. The power of OCI is that it's pretty secure. I think a lot of us were familiar that you get things like SBOMs, you get immutability, you can sign the creation of these artifacts. You get better, more fine-grained authentication. You're not giving access to a whole Git repository where you've got loads of shared documents. You're just giving access to one particular image in that registry. And it's just got a lot of sort of nice aspects to it. But then you have to come back to why we were using GitOps to begin with. If you're losing that sort of user nature of being able to go and look at the commit history and all that sort of stuff, it's an interesting trade-off about using, should you use this? Should you use Git? Should you use S3? And we think the flexibility of being able to choose between them is really important. You need to use the right solution for the right problem. So adding OCI support to Kratix is something that's on our backlog to add support for. So in summary, in this talk, we talked about GitOps and why it's really powerful. We talked about how it's a principle that doesn't just apply to Kubernetes. Any system where you can you can converge on a declared state in a Git repository, an S3 bucket, or anything like that, is essentially doing GitOps. We talked about the importance of tracking the health of your workloads, particularly once you scale this out beyond Kubernetes. If you're using different systems, you need a way of putting all that information back in. And we talked about how GitOps doesn't just mean Git. So this is it for the talk. Me and Chunyi will be at our booth later today, coming to talk to us. We're also giving a workshop later today as well. It's the Working Code Win workshop. We'll be sort of walking through what it's like to build a platform using Kratix alongside some open source tools. And our colleagues, Kat and Derek, will be giving a talk tomorrow on adding observability to Kratix as well. So thank you all for coming.